Alright, last time you guys were here, we were working on a sound wave experiment. You guys went out on the field, and we stood a certain distance away from each other, and we started to scream at each other to be able to see how long it would take the sound to travel from one end of the field to the other. So now that we have all that data, we need to go ahead and graph our data. First thing a scientific graph needs is a title. Now, a lot of times you guys like to make titles that are cutesy, titles something like "Sound is Fun," or something like, I don't know, "Sound All Around." It shouldn't be a clever title. It shouldn't be cutesy. It should be a scientific title. Scientific titles should be descriptive. So instead of doing a cutesy title or something that's clever, we're just going to be extra boring because it's science, so it needs to be sciencey. So we're going to call this sound travel times, and we're going to call it time versus distance. Now in the future, I will expect you guys to be able to make your own graphs, to be able to make logical titles that make sense, to be able to figure out the spacing in between the numbers. But for this graph, I'm going to go ahead and walk you guys through, since it is the first graph that we have actually made this year. Now we don't just have a title at the top, we're going to have the title on the y-axis as well as the horizontal or x-axis. Now I want you guys to think which axis, well, first of all, you guys should know that we're going to be graphing our paces versus our time, since that's all the data that we actually had. But I want you to think to yourself, what should go on the x-axis? What should go on the horizontal axis down here? What would be the best variable to put there? Alright, hopefully you guys came up with distance. And if I just put the label here, distance, that actually wouldn't be good enough, because I need to be able to say what units my numbers are going to be in. Now, we didn't do a very scientific unit. We used paces because it was quick and easy for us, but we're still going to put that down. So we're going to say distance in paces. Alright, so go ahead and write down distance in paces and put that title at the bottom of your graph. Now we're in distance on the bottom for a couple reasons. One, when you're doing a graph, almost always, unless you're using some kind of engineering techniques, you will have distance graphed on the horizontal, the x-axis, almost every time. So if you're trying to figure out which way it should go or where something should go, if you have distance, distance is going to go across the bottom almost every single time if there is distance. Now, the second reason is because it is the independent variable. It is the variable in the experiment that we changed or altered. This is the one we were controlling. And the outcome, which goes here, the dependent variable, the outcome of the experiment is going to be what you graph on the y. Now, in our experiment, that was time. So what you're going to do is you make a label, and we're going to put it up here and make that time. Alright, so now also make sure you're not just saying time, but what units are you talking in? Is this time in eons? Is it in hours? Is it in days, weeks, years, seconds? We measured in seconds, so make sure you put down in seconds. Now the distance in paces, well, we just did that out on the field, so we're just going to start with 0 being right here, and then we're going to go ahead and go up in paces. We went up in 20 paces. Sorry, I said we were going to start at 0. We're not going to start at 0. We're going to start what we started at. So for your class, that might have been 10 paces. It might have been 20 paces. It may have been 0. I doubt it was. It may have been 50. So whatever your class is, that's what you're going to put there. That's what number you're going to start in. Now, For this class, it looks like their paces, they started at 20, and then they went up 20 paces every single time we had a trial. So for this class, we would start our numbering system at 20. So go ahead, pause the video, and put in your distance along the x-axis, starting at whatever your first trial was at, and then marking it every single 20 or 10 or whatever your group did along the way. Now I'm going to go ahead and do that, and when you push play, you'll be able to see the example of what I have. Okay, so I've got all my numbers here, starting with 20, the first number that we recorded at. Again, I said if your group started at 50, you'll start at 50. There's no really reason why we'd start at 0, unless your group actually started at 0, which it didn't, because we have no data that's going to be in that part of the graph. Alright, so once you've got each one of these major grid lines marked out at one of our paces, we're going to go ahead and start marking up the side in seconds. Now, a lot of people would want to start with 0 and then go to 1 and then go to 2, then go to 3, then go to 4. The problem with that is if you took a look at your data for a second, you would notice that we have decimals. We have 0.79 for this one, 1.08 for this, 1.33. We're measuring all the way into the hundredths. So what we really should be doing is we should take a look at our data. This data specifically looks like they probably actually only had 19 trials. So I'm probably only going to graph it out to 19. But their data here looks like it stops at 2.5. Now, none of the other data goes above that mark. Now, the smallest data is going to be 0.79. So if I go back to my graph, I'm probably going to start at the bottom of the graph at 0.5 and then work my way up somewhere to 2.5. Now, to figure out how I should space that, I'm basically going to want to say, okay, can I go up by 0.5? Would that give my data a good representation? Should I go up by 0.25? Do I have enough space for that? So basically what you want to do when you're looking at a graph is, one, how high do I want the graph? You don't want to have it so spread out that the graph looks a little bit distorted, but you want to have it a good representation of your data. Looking at this data, I think it'd be best if I went up by quarter, but let's see if that works. So I went 25, 50, 75, 1 second, 25, 75, sorry, 50, 75, 2 seconds. It looks like it'll fit plenty on my graph. So I'm going to go ahead and mark out my graph at half seconds, quarter seconds. Now, if you want to start this at 0, you go ahead. I'm actually going to do that because we're really close to 0 anyway. And so I'm just going to mark my y-axis in quarter of seconds. I'm going to go ahead and do that. And then you can see my example and then pause the video so that you guys can get that done on your end. Okay, so here I've got all my time here on the y-axis, the vertical axis here. We've got our labels on our graph. Now it's time to graph. Now, most of you probably know how to graph an XY plot, which is awesome. That's really going to be helpful. But we're going to make a graph that you guys probably are not used to. It's called a scatter plot. So what I want you to do is I want you to take all your points and you're going to graph them on your graph, but you will not connect the dots, which is probably contrary to what you're used to, because we science teachers have probably been screaming at you for years to connect the darn dots. But on a scatter plot, we're going to do something different. So what I want you to do is you are going to take all of our data, you're going to plot it like an X. X is going to be our distance, Y is our time, and plot them on the graph. If I switch here to period 3's data, you can see that here on the graph. I'm going to have my X is going to be 20, my Y is going to be 0.79. Now when I switch back here, I'm going to estimate the best I can, 20 to 0.79. It's going to be a lot closer to 7.5 than it will be to 1, almost right on the line, and I am going to go ahead and make my point there. Move to the next plot. We've got 40 plotted against 1.08. I'm going to move to my 40 paces. 1.08 is pretty much really darn close to 1. Go ahead and make your dot there. Go ahead and plot all of your plots in the X, Y, with distance being your X, Y being your time. Get all your dots on there. Pause the video till you have that done, and then I'll show you what we're going to do with this XY scatter plot graph. Okay, so here are all my dots on the graph. Now, if this were a line graph, you'd want to take your pencil or pen and start connecting all of the dots. If you wanted to make it a rounded line graph, you would curve it so that the graph would move along, but we're not going to do that. We know we had some human error in our data collection. We know that we may not have been the perfect here. So what we're going to do is we're going to get an idea or an average of what our data says. If you haven't finished plotting your dots yet, pause the video before you move on. So the next thing we're going to do in this scatter plot is we're going to see how the data is represented. We're going to use what's called a trend line. Sometimes people also call this a best fit line. I like trend line better, but best fit line is better for a lot of people because it kind of describes what this is. We're going to see how the data is best represented. Now, you are going to do this. You're going to eyeball it. You're going to see where is a line. We're going to draw a straight, perfect line in between all these points that kind of makes an average of all these points. Now, if you were to use a computer, the computer would actually use a mathematical calculation to be able to determine exactly where this line should be. We are going to, like I said, eyeball it. What you're going to do is you're going to take a line, try to make a line go in between all your points so that there are just as many points above your line as there are below. Obviously, I haven't quite done that, so I'm going to redraw my line again. That's a better average. It hits some of my lines, and that's okay. And honestly, just because I'm a little OCD right now, I don't like the thickness of my line. I'm going to go ahead and try to dry that. So grab yourself a ruler. What you're going to do, put that ruler down to where it is almost averaging the data, and I want you to draw a nice, good trend line on your graph. That's pretty close. Not perfect. It'd be better if I used the formulas, but I'm not going to go that far, and neither are you. Why don't you go ahead and draw your trend line so we can see what the data is saying, how the data is represented, and then we're going to interpret our graph. So pause the video, get that line drawn in, and then we'll move on to the questions. Okay, hopefully you've been able to draw your trend line, and you should see that our trend line is going from this point up to this point. The trend line is increasing on our graph. So what I want you to do is either on the back side of your paper or the bottom of your paper. You probably should turn to the back because you're going to need more space, but you could start at the front if you wanted to. I want you to put number 1 down, and the first question is you need to interpret the graph. When you look at the graph, this graph, what does it say about our data? Meaning, now this is the part I really want you to answer, when distance increased between the two larger groups of people, what happened to time? So when the distance between us, so when we had more paces as we go this way on the graph, what happens to time? Think about it. Write your answer number 1 on your paper. Pause the video. Okay, now that you have number 1 answered, it's time to attempt to answer number 2. And number 2, referring to question number 1, if time increased each time there was more distance between the two groups, what does that reveal to us about sound? So if every time we got further and further away from each other, it took longer and longer for the sound to reach us, What does that tell us about sound? What information does that give us about sound? Think it for a minute and give your best answer. Pause the video. All right, question number 3 is going to make you think a little bit. If you're not thinking a little bit, you're probably not answering the question correctly. All right, so number 3, sound travels in a wave. In the case of our experiment, our voices compressed air molecules and then stretched them, allowing the sound wave to travel. If you were watching during the experiment, you may have noticed that you could see the other group say hey before you could see it. Sorry, that didn't make sense. Before you could hear it. There, I fixed it. So you could see them say hey before you could hear them say hey. Listen to the following prompt and then choose an answer from the following options. So I'm going to read through this one more time, just so everyone kind of understands what I just said. So sound travels in a wave. In the case of our experiment, our voices compressed air molecules and then stretched them out, allowing the wave to travel or propagate. If you were watching during the experiment, you may have noticed that you could see the other group say hey before you could hear them say hey. So now what you need to do is listen to the following prompt and then choose an answer from one of the following options. Then, and this is the important part here, you need to explain why your response is correct. Okay, so on number 3, this is what you're going to write about. If sound takes time to travel, explain when the opposing group yelled hey. Did they A, yell hey when you heard them yell it? Did they yell hey when you saw them yell it? Or are neither of those options correct? Is C correct, meaning neither when you saw it or heard them yell hey? So again, you need to respond to this prompt. If sound takes time to travel, explain when the opposing group yelled hey. Was it A, when you heard them yell it? B, when you saw them yell it? Or C, neither when you saw them or when you heard them yell? You need to choose A, B, or C. Then you need to explain why whichever one of those options you chose is the correct response. Pause the video and respond to that prompt. All right, question number 4 is the last question. Yay! Our question number 4. Light travels in a wave as well. It travels as a different type of wave, however. Light travels in what is called an electromagnetic wave. This type of wave can travel without a medium, or in other words, it can travel through the nothingness of space. Using your experience in this lab, explain to me how sound and light might be similar. So I want you to respond to that prompt. Question number 4. When you're done, put your name, or make sure your name and period are on the top of your paper, and place this assignment in the inbox. This will be the last assignment that's going on your grade for this term. Those of you in my regular classes, you need to work on your missing work. If you have work from another class that you would like to work on because you have everything made up of my class, or your grade's pretty fine in my class, meaning it's a C or higher, go ahead, feel free to work on that as well. But the fact of the matter is, the end of the term's coming up. You guys need to get your grades up. because everything will be final in 2 weeks. So work hard today, answer this last question, and then put it in the box.